Yes دكتور أنا سويت.
Okay. So we are going to solve number 7. You have y1 dash equal to 2y1 sorry, y1 dash equal to y2, sorry. Okay, and y2 dash equal to minus y2. y3 dash equal to minus y2. And y2 dash, I miss y3 here. Okay. Now this is a system of differential equation. Can we write this one in terms of matrices? Yes. I can write this one as y1 dash, y2 dash, y3 dash equal to, what is the coefficient matrix? Can anyone let me know what is the coefficient matrix?
0, 1, 0.
Okay, 0, 1, 0, and then
لا دكتور أنا أقصد بالطول بالعرض.
rows. I mean, sorry. 0, 1, 0, and then
0,
0,
minus 1,
excellent,
1,
1, and last
0,
one, 0,
minus 1, 0.
excellent, thank you. And here I have to put the variable y1, y2, y3. Okay. Now the main point here to solve using the eigenvalues eigenvectors, I have this matrix A in Matlab as 0, 1, 0, and then semicolon, the second row, 0, minus 1, 1, and then semicolon for the third row, 0, minus 1, 0. If you have Matlab, please do it to give me, this is a matrix, and then I make a semicolon outside, and then how to find the eigenvalues and eigenvectors using the Matlab. I have the same command, erg, coming from eigen for the matrix A, but this one will give me only the eigenvalues, but I'm looking for the eigenvectors. So before this one, I'm asking him to have the input as a vector and diagonal matrices with the eigenvalues, right? Let's go for the Matlab. Okay. I have to input the matrix first. 0, 1, 0. Try to do this one with me, please. Minus 1, 1, 0, semicolon, 0, minus 1, 0. Then semicolon, I have to say, please give me the vectors and give me the diagonal matrices with the eigenvalues using the command erg for the matrix A, and should be square matrix, of course, and then just yes. Here I have a complex number, right? And I have each one here as eigenvectors, also complex number. Okay. So what you are going to do after you find this one using by hand, either by hand or by the Matlab, what is your solution now? Your solution should be what? y1, y2, y3, equal to what? Can you tell me? Guys? Yes, I hear you. You said C1. Okay. E to the lambda 1. If your variable x, you can write x. If your variable is t, write t. So I consider it as t because I don't have it here, so I can consider it t. And I have my first eigenvector plus a second constant, c2, exponential function of the second eigenvalues, and then the second eigenvector, and the last plus the third constant, and I have the exponential function of the third, and finally I multiply by the last eigenvector. Why I have three constant here? Because I have system of three differential equations, right? And also I have three dependent variables. This is the main point. I have three dependent variables. This is why I have three constants. Okay, so what you are going to do, you just go to your Matlab. Okay, you go to your Matlab and you just replace lambda 1 and lambda 2 and x1, which is the first column. Forget about this 0. You just take only this one, right? And also this is 0, right? All of this one 0, right? So e to the 0 will give you 1, right? You take the main diagonal here. This is your eigenvalues. Okay, so you have 0 here for the lambda 1, and you have 0.5 plus 0.8660i, and the lambda 3 is 0.5. Of course, it's the conjugate of the second one, because if you have a complex root, the conjugate will be also a complex of your function, or a root of your function, or solution of your equation, right? So this is only what you're to do. X1 is 0. This is 0, and this is 0 and 1, right? Okay, so I'm going to write now how to write the eigenvalues from here. What's your lambda 1 here? So lambda 1 equal to what? 0. Lambda 2 equal to what? 0.05 plus 0.866i, and lambda 3 of course will be the same but with negative for the imaginary part. Okay, this is the eigenvalues. The eigenvectors x1, yes, this is the first column here, right? All of these one are zeros except this one is 1. So you have 1, you have 0, 0, 1. What's your x2? Your x2 is the second column here. So I have minus 0.5774. Okay. Minus 0.866. 0.2887, 0.5774. Okay, and here you have plus 0.5i. Okay, your last one, x3, which will be the last column, the third column here. It will be minus 0.5774. Okay, there is 0 with the imaginary part, and here you have minus 0.2887 plus 0.5i, and you have 0.5774 plus, there is nothing here. So now you just come back here and you replace your lambda and your eigenvectors. Okay, of course you can, this is a most difficult one using by hand, but if you have a real, it will be easy for you, right? Can you please stop recording for this one? Unless you have any question about this one, but you would like me to repeat